So now that we've learned how to record measurements with the correct number of sig figs, and we've learned how to count sig figs in a measured recording, now we're going to look at what are we going to do when we start working with significant figures in calculations. So in physics, we process data mathematically. There's going to be a lot of math in this course. And it doesn't make any sense for a calculated value to be more precise than the measured data that went into the calculation. For example, if you were to take these three digits, so 34.6 times 12.1 times 1.2, you get 502.392, which is 6 significant figures. But in my question, I had a number that had 3 significant figures, 3 significant figures, and 2 significant figures. So how can I answer with more precision than any of my data was given with? So what we're going to learn is 2 rules. There's a rule for maintaining significance with multiplying and dividing, and then there's a rule for maintaining significance with adding and subtracting. When you're multiplying and dividing, the key thing is that you maintain significant figures. So you're just limited by the lowest number of sig figs in your data. So for example, here we had 3 sig figs, 3 sig figs, and 2 sig figs. So we are going to be limited by this 2 significant figures, which means if you look at this number, your last digit to be retained will be the 0. Now, this number is kind of a tricky one, which is why I put it in the example, is that if you want to maintain 2 sig figs, there's actually no physical way of writing 502.392 with 2 sig figs, because 500 would have 1 sig fig, 500 decimal would have 3 sig figs, so we actually have to write it in scientific notation. So that's why this answer is written as 5.0 times 10 to the 2. Even though 500 seems like a weird number to write in scientific notation, sometimes it happens when you're maintaining significance that you have no choice. Now, this won't happen very often, which is why it's in here, but we're going to try these rest of these questions, and I guarantee probably, I don't want to say for sure, I can't quite remember, but I don't think any of them do we have to write them in scientific notation unless we want to. So first question here, we've got 3.40 times 130,000. First thing we're going to do is just type that into our calculator. So I'm going to put 3.4, because the 0 doesn't matter to the calculator, times 130,000. And I get 442,000. Now, am I allowed to give this as an answer? Well, we're going to check for sig figs. This number has 3 sig figs. This number has 2 sig figs. So we are limited by the 2 sig figs. My answer can't give more than that. So I have 2 choices. I can say, okay, 442,000. If I'm going to round to 2 sig figs, this 4 is going to stay the same, and then the 2 would just go away. So I could write it as 440,000. Or, like I taught you with scientific notation, it's kind of nice just to not worry about everything coming after and say that if I was going to write 44 in scientific notation, I'd put 4.4 times 10, and then my decimal place would be here. I'd go 1, 2, 3, 4, 5 places. So either of these answers is perfectly fine, and this final answer would have 2 sig figs. Okay, let's try one more together. So I've got 1.40, or I'm just typing into my calculator 1.4, divided by 2. And then this gives me 0.7 in my answer. Well, this number has 3 sig figs. This number has 2 sig figs. So I have to answer to 2 significant figures. How many sig figs do I have here? Well, I only have 1. So I can turn this into 2 sig figs by writing it as 0.70, or if I weirdly wanted to write this in scientific notation, I put 7.0 times 10 to the negative 1. So this would give me 2 significant figures. Does that make sense? Hopefully. Try these 4. So if you're not ready to just try, you can stay with me, but at some point it'd be good to pause the video. So for this one, we've got 4.0 divided by 4.000. In other words, we've got 4 divided by 4, which we know is 1. But let's look at our significance. This has 2 sig figs. This has 4 sig figs. So I'm limited to my 2 significant figures, which means I would write my answer as 1.0 to 2 sig figs. All right, what about the next one? 3.042 times 5.23 is going to give me 15.90966. I've got 4 sig figs in this digit. I've got 3 sig figs in this digit, so I'm going to limit this to 3 sig figs. Because it's a 0 next to the 9, I'm going to keep it as 15.9. Now again, you could write that as 1.59 times 10 to the 1, but I don't know, personally that feels silly, right? So either of those would be absolutely fine. All right, C and D. C, we've got 54.67 divided by 0.02, which is going to give me 2,733.5. Then I've got 4 sig figs divided by 1 sig fig, which means I'm limited by the 1 sig fig. So I'm going to round this guy to 3,000, right? Because maintaining it. Now this is one of those ones that might be nice to write in scientific notation. So if I have 1 sig fig, the 2 rounds to a 3, and then I put times 10 to the 1, 2, 3. Okay, either of those is great 1 sig fig answer. This is 2 sig figs. And this is 3 sig figs. All right. This next one, so I'm just making sure my notes all look the same. Should have circled this guy. All right, this next one we've got 5,678,342, and I'm multiplying that by 2.3. Ooh, that's a big number. That's going to give me 13, how can I read this? 13,060,186.6. Okay, so what about significance? This guy has 7 sig figs. This one has 2, which means I'm limited by my 2 sig figs. Now, personally, I would write this in scientific notation. I don't like having to write a bunch of zeros, so I'm going to take these 2 sig figs and write this as 1.3 times 10 to the 1, 2, 3, 4, 5, 6, 7. Or if you really wanted to, you could put 1, 3, and then fill in zeros. 0, 0, 0, 0, 0, 0. Awesome. So either one of those, I have 2 sig figs. So multiplying and dividing is pretty straightforward. You know, you just count the sig figs in your question and then you answer to that many sig figs, and you have 2 choices. You can write every answer in standard form or scientific notation, whatever makes the most sense to you. It's totally up to you. But now let's practice that scientific notation thing. So sometimes our numbers in our question will be in scientific notation, and it's really good to be able to A, put these into our calculator in scientific notation, B, be able to read an answer in scientific notation, and C, maintain significant figures. So what we're going to plug into our calculator is 6.02 times 10 to the 23 times 4.155 times 10 to the 9. And I'm going to ask before we plug this in, how many sig figs should be in my answer? Well, I have 3 sig figs and I have 4 sig figs, so I'm going to answer to 3 sig figs. But let's see how we type this in. So if I was going to type in 6.022 times 10 to the 23, I type 6.02. Now, everybody's calculator should have either an EE or an EXP button. Okay, so I just went online to find a calculator so I could show you what this looks like. So this calculator has the EE button. It'll be very similar if your calculator has an EXP. But what I'm going to type in is 6.02, and then you just type, like you hit that EE or that EXP button. Now this calculator puts an E in there. Some calculators will automatically put a times 10 to that. But because I've hit this, I no longer need the times 10. My calculator now knows I'm in this notation. So I'm just going to type 23. So this calculator knows that this is 6.02 times 10 to the 23. In fact, let's just show you a smaller number. Like if I put 2.3 EE4, that means 2.3 times 10 to the 4. So if I hit equals, it's going to show me 23,000 as an answer. So when I'm plugging this in, I'm going to put 6.02 EE. Don't hit any times 10s to that, just put a 23, and now hit times, and I'm going to put 4.155 EE or EXP 9. So that's telling my calculator not only am I doing times 10 to the, but it's also telling your calculator that this is a number. it's almost like it's putting it in brackets, that it knows the times 10 to the 23 is attached to the 6.02, and it just kind of helps with some of the functions or notations that you're going to be doing. So then we hit equals. And now, because this answer is so big, my calculator can't give it to me as a full standard answer, so it gives it to me in scientific notation. So this calculator reads 2.50131 times 10, because E is replacing that times 10, and some calculators will say times 10, and then it puts the 33. So I've put this into my calculator. It's going to give me, let's see if I can remember this whole thing, 2.50131. So it gives me 2.50131 times 10 to the 33, but then I know that I have to answer to 3 sig figs, so I'm going to keep these 3 sig figs, and then that would be my final answer. So now what we're going to do is just practice plugging some things into our calculator. So let's try this first one off the bat, and then this one try, but I kind of want to mention something before you do. So plug this into your calculator and answer to the correct number of sig figs. So 8.85, my calculator in my hand is exp5 times 6.7 exp4 times 1.23 exp negative 11. That's probably really annoying for you. Okay, now this one gave me an answer of 0.7293285. It didn't give it to me in scientific notation because it didn't have to. Every calculator has its own limit. Some calculators are like, oh, there's 4 decimal places, scientific notation. Some calculators are like, until I hit the end of my screen, I won't write it in scientific notation. And then some calculators you can set up so that it'll give you every answer in scientific notation, which can be kind of nice as well. So for this one, what are we going to do? Well, we've got 3 sig figs times 2 sig figs times 3 sig figs, so I know I'm going to answer to 2. So I could just take this and say it's 0.73, and that's a great answer. If you wanted to, you could put 7.3 times 10 to the negative 1 as well, but that is my answer to 2 sig figs. Now this next one, I wanted you to wait for me because I really want to point out something. If I was to plug this into my calculator, let's actually just do it. So if I took this question and I plugged it into my calculator as it's written, so I'm going to put 3.25 times 10 to the 15. Now don't copy me because I'm going to do this wrong. Divided by 4.7 times 10 to the 3 times 6.23 times 10 to the negative 4. Can anybody see the problem? You have to think about order of operations. My calculator is going to do this divided by this, and then times the answer by 6.23 times 10 to the negative 4, which is going to give me the wrong answer. So I have 2 choices. Option number 1, you can throw in some brackets. I can tell my calculator, hey, I'm doing 3.25 times 10 to the 15 divided by this operation of 4.7 times 10 to the 3 times 6.23 times 10 to the negative 4. This will give me the right answer, okay, which, now let's just record our answer. So this is 3 sig figs, 2 sig figs, 3 sig figs. So we're going to answer to 2 sig figs. So 1.1 times 10 to the 15. Okay, so you can do it like that, or if anybody doesn't like brackets, I generally find that people, this is the majority of ways people are going to do it, they just always put their numerator and the denominator in brackets. But if you wanted to, you could actually change that to a division symbol, and you could say, hey, this is 3.25 times 10 to the 15 being divided by 4.7 times 10 to the 3 and being divided by 6.23 times 10 to the negative 4. And this will also give me that correct answer. Okay, but again, if, now that you've seen it twice, if I just forget the brackets or don't do 2 divisions, I get an entirely different answer. So be careful. Okay, so these are my 2 answers to this question. This one is 2 sig figs as well. Okay, and I want you to give these 2 questions a try. Okay, so the first one I'm going to plug in. Oof. So my calculator didn't give me this answer in scientific notation. This one gave me 1260273,973. brutal. And so what I have to look at is 3 sig figs divided by 4 sig figs. I'm going to answer to 3. So I'm going to take these digits and I'm going to write it in scientific notation. I don't want to write zeros. If you wanted to, you could trail all of these as zeros, but I'm going to put 1.26 times 10 to the 3, 6, 9. And that's what I would give as an answer. All right, what about the next one? Have you plugged this one in correctly? So 2 choices. 1, if you want to be safe, just always put numerators and denominators in giant brackets. Actually, I'll show you how I plug this one in. Okay, so if this was my question, sorry, I was just thinking. Yes, if this was my question, this is how I would plug it in. I would do 287 times 7.07 EE negative 8. Now, some of you might not be allowed to use this negative, like the subtraction sign is a negative. Some people might have to use like, I didn't even realize this one had it. I could put negative 8. This calculator was letting me and it didn't care. But I always type in my numerator and then I hit equals and then I hit divided by and then I would do the bracket 3.76 EE6 times 7.3 EE4. To save myself brackets, I will hit equals and then divided by, and then it always says, hey, now you're taking that previous answer and dividing it by this. And it just is helpful. I do also want to point out that the less you can write things down, the better. I find as soon as people start trying to write, like they'll do this and they'll write the answer down, and then they'll do this and then they'll write the answer down, and then they'll divide the two. It's too much, and physics has so many calculations. You need to get good at your calculator. So either enter it in as bracket this divided by bracket this, or 287 times this equals, hit divided right away and it'll say answer divided by, and then put in brackets the denominator, or divide. or. Okay, 3 sig figs, 3 sig figs, 3 sig figs. Oh, there's another 2 sig figure. So I'm going to take my 7.39 and write it as 7.4 times 10 to the negative 17. All right, so that's the end of this first part, which is maintaining significant figures in calculations where you are multiplying and or dividing.